It was a magical time when, in an instant, the Andromeda cloud turned into the Andromeda Galaxy. For many years, observations made from Earth were the only way we knew how the Andromeda Galaxy worked. With the help of better technology and the launch of the James Webb Space Telescope, however, our knowledge has grown beyond all measure. Now, things are about to change because the James Webb Space Telescope has found signs from the Andromeda Galaxy that are very scary. Scientists are still trying to figure out what these signs mean. Astronomers are both inspired and curious about them. But what do these signs really mean? The most important question is why they are making scientists so upset. Just 2 minutes ago, the James Webb Telescope turned off because it got alarm signals from the Andromeda Galaxy. Astronomers thought the Milky Way was the whole universe before we could see very far into space. This lack of understanding was mostly caused by the fact that scientists didn't have the right tools to see different galaxies and individual stars. But when we found the Andromeda Galaxy, everything changed. It was the first sign that the universe is much bigger than the Milky Way in our minds. In the 1600s, Galileo Galilei's groundbreaking work with binoculars showed what the Milky Way really looked like. He saw that the Milky Way had many stars, which went against the idea that it was the most important thing in the universe. In the 1920s, Edwin Hubble used the Hooker telescope to find faraway objects beyond the Milky Way. This changed everything. It was Edwin who noticed that these moving objects in space were galaxies other than the Milky Way. The Andromeda Galaxy, or M31, was one of them. Abd al-Rahman al-Sufi, a Persian scientist, first wrote about the Andromeda Galaxy around the year 1050, but this was the first time we saw it through a telescope. Astronomers were able to see and understand what Andromeda was really like because of progress in technology in the 20th century. Andromeda is a cloud of gas and dust made up of a very large galaxy of stars, like our own Milky Way. Our friend in space is about 2.5 million light-years from the Milky Way. The way we study Andromeda has changed a lot since it was first found, from using telescopes on the ground to using space telescopes like the Hubble and the James Webb Space Telescope. We have come a long way, and with each new piece of technology, we've reached new heights and learned more about the Andromeda Galaxy. Given that we now know more about its makeup and structure, Andromeda has become a standard for studying how galaxies form and grow. This has given us more information about how the universe works in a bigger sense. Scientists think that we need to study the link between Andromeda and the Milky Way to learn more about the universe. This is especially important since the two galaxies will eventually crash into each other in about 4 billion years. Even though research and studies have moved forward, the James Webb Telescope recently got a signal from Andromeda that made scientists worried. Scientists all over the world are confused by this worrisome signal, which has led to questions about where it came from and what it might mean. The advanced sensors on the James Webb Telescope have found strange behavior right in the center of Andromeda. The signal sent back to scientists shows results that are very different from what has been seen before, which interests scientists all over the world. The signal shows that there are big things happening inside the galaxy, which might have something to do with its giant black hole or with things that haven't been seen before. One of the most recent discoveries is that Andromeda's mass might be much larger than the Milky Way's. This changes how we think about the sizes of both galaxies. The James Webb Telescope has also taken very clear pictures and spectra of Andromeda, which have shown how new stars are made and what chemicals they are made of. This new information is important for knowing how galaxies have changed over time and what conditions might be right for life. The telescope data also shows that Andromeda's active galactic center is becoming more active, which will have an effect on its surroundings and determine how it will be structured in the future. Researchers are also learning more about how mysterious dark matter is spread out in the galaxy by studying the effects of gravity on stars in Andromeda. This should help us better understand how dark matter affects the physics of the universe. As it stands, one of the biggest mysteries in astronomy is dark matter and how it affects the world. Recent discoveries made by the James Webb Telescope have sparked many studies around the world as astronomers try to figure out what Andromeda is all about. We now know more about the past and future of the galaxy because new knowledge has come to light. So, what do different studies tell us about the Andromeda Galaxy? There are some amazing things about Andromeda that set it apart from other galaxies. People are amazed by how big it is. New estimates put its width at about 220,000 light-years, which makes it one of the biggest galaxies in our group and even bigger than the Milky Way. Its mass comes from its huge size. It is made up of about 1 trillion stars, which is more than our galaxy. Scientists are also interested in how the galaxy is put together. Andromeda is not like most spiral galaxies because its center bulges, and its dense core is surrounded by rings of dust and gas. This makes it a great place for stars to keep forming. One of the most interesting things about it is its center, which has a double peak emission that suggests it has a supermassive black hole similar to, but not the same as, the Milky Way's. This gives us important information about these huge holes that eat matter and what they do. Andromeda is also surrounded by a sphere of stellar junk that is hundreds of thousands of light-years across and made up of stars, planets, and globular clusters. This space cover tells an interesting and thorough story about how the galaxy came to be and its past. The 460 globular clusters found in Andromeda also give us information about how stars form in their very early stages. This makes it easy to understand how star clusters form and how the galaxy first formed. Astronomers are getting closer to knowing what dark matter means in the big picture by putting together the puzzles of Andromeda, but there is still one question. How do they explain how mysterious it is and what part it plays in how galaxies move? Andromeda also has something else that makes it stand out: galaxies that orbit around it. It has more than 20 smaller galaxies making up its halo structure. Some of these galaxies are losing their stars and gas to the tides. Small galaxies that are nearby are pulled in and destroyed by a bigger galaxy. This shows that cosmic evolution is active and shows how galaxies grow and interact with each other over time. How will things go from here for the Andromeda Galaxy? Astronomers and people who want to learn more about the universe are both interested in its shape and the way it moves. Andromeda's growth is based on the idea that it could change from a spiral galaxy to a ring galaxy. There is evidence of a process that could lead to other rare pairings. This process could be caused by galaxies colliding or interacting closely with each other. If Andromeda is really moving in this way, it means that since it was born, it has had a lot of deals with other galaxies. In the end, Andromeda's future rests on its impending collision with the Milky Way. Based on these models, the impact is thought to happen in about 4 billion years. After such an impact, these two very large celestial bodies will give birth to a new galaxy. Even though it's bad, the impact is a normal part of how galaxies grow and change. Galaxy collisions don't have direct impacts, though, because the galaxies are so far apart. When the two galaxies collide, they will have completely changed forms and compositions as their gases and dust combine. New stars will be born. This will make for a spectacular show in the sky as the objects merge and shine brightly. Finally, this kind of cosmic event will cause a single irregular galaxy to form. The universe has a long history of collisions like this one, but the fact that we can directly take part is what makes it interesting to us. The expected collision of the supermassive black holes at the centers of the two galaxies adds even more mystery to the show in the sky. This shows that the evolution of the universe is very complicated and deep. It is thought that the merger will cause blasts as matter is sucked into the black hole, which will release a lot of radiation. This process gives us useful information about how galaxies change over time and how black holes impact this change. But it brings up an important question. What will happen to our solar system after this merger? The solar system would not be destroyed completely, but its direction and conditions could be changed a lot. This means that the orbits could change or even be ejected from the newly formed galaxy. To figure out how this process works, scientists can look at how similar events are and try to figure out what will happen to our galaxy in the long run. Because the space between galaxies is so big, it is important to know that star collisions don't happen very often, but the change in gravity could throw off stars' fixed orbits, which could cause some stars like our Sun to change their paths. This kind of change could really mess up the climate on Earth. Moving farther or closer to the Sun is one of the most important changes people can go through. This could either make things warmer or cooler. If it gets colder, a new type of ice age could start. If it gets warmer, ice caps could melt and sea levels would rise. In addition, the shape of such a setup could mess up the amount of radiation coming to Earth, making things even more difficult. The fact that the Andromeda and Milky Way systems have joined together shows how complicated the relationships are between heavenly bodies. As time goes on, The black holes in both galaxies may get closer together, which could make it easier for high-energy particles to reach Earth. This could lead to more cosmic radiation getting through our atmosphere. A possible rise in radiation levels could be bad for the world's ecosystems because it could cause people to change faster and lower the variety of life on Earth. Because the black hole merger would change the path of Earth's natural orbit or axis, it is likely that the way settlements are spread would be affected. One effect of climate change seen around the world through changes in biodiversity and ecosystem structures is how organisms will live in climate zones that may become less favorable. There are some species that might do well in the new environment, but others would die out or become very rare. As the clouds of gas from the nebula come together and get squeezed together, new stars will likely form. If this process happens close to our solar system, the radiation from these young stars could change the environment, which could have a big effect on the temperature and the whole ecosystem. It's true that these events shape the big story of how the universe evolved, but it's also important to know what happened before and after them. There are events that happened after the impact that happened billions of years from now, and people may have changed a lot. It's possible that we already live somewhere else in the world or even outside of it. Exploring the Andromeda Galaxy seems to be the key to figuring out how our own galaxy has changed over time and what the future holds for it. The differences that people think exist between Andromeda and our galaxy can be used to make more accurate models of how galaxies move and change over time. Reevaluating Andromeda's size and mass is a good idea because it helps us learn more about the Milky Way and how it is put together. So, it has broken our first ideas about Andromeda and made us think again about what it means in our galaxy's neighborhood. According to new information, the Milky Way and Andromeda galaxies are about the same size, not much bigger than ours. This goes against what we know about the Milky Way's place in the neighborhood group of galaxies and how much gravity a galaxy like this has. At the moment, the Milky Way looks like a barred spiral galaxy, but when it interacts with the Andromeda Galaxy, which will almost certainly happen soon, its shape could change. Keeping an eye on how Andromeda changes over time helps us figure out how the big galaxies change. A lot can be learned by looking at where Andromeda is now and guessing where the crash will happen in the Milky Way. The rate of star formation and the distribution of gas and dust would change, and so would the cores of both galaxies. This is what cosmologists would describe. New technologies in astronomy have made it possible to make this model. These technologies have also greatly expanded the fields of study in space. Because of this, each trip has been better than the last. The journey began when the telescope was made in the early 1600s. This allowed scientists to see how Jupiter's moons moved around the planet and how Venus changed phases. The technology behind telescopes got better over time. During the late 1800s and early 1900s, bigger and stronger binoculars were being made. Astronomers found new planetary bodies like Neptune and made it easier to reach the world beyond Earth. Even though the atmosphere and light pollution made it hard for ground-based telescopes to work, they were still able to reveal amazing things about the world. We made a huge step forward in space research when the Hubble Space Telescope was launched in 1990. Hubble not only gave us a better view of the world from higher above Earth's atmosphere, but it also almost completely got rid of Earth's disturbing haze. This led to more depth, clarity, and views than ever before. The Hubble helped us learn more about black holes, how old the universe is, and how space is expanding. Right now, along with the Hubble Space Telescope, other space telescopes like the Chandra X-ray Observatory, the Spitzer Space Telescope, and others added to what we know about the world. They looked at the universe from space, away from the things that got in the way on Earth. In addition to light, telescopes, radio, infrared, and X-ray observatories have given scientists a lot more tools they can use to look at the sky. Scientists can use these tools to not only find but also study a wide range of things. This includes the microwave background radiation of the universe, areas where stars are being formed, and the leftovers of supernova blasts. But dark matter is still one of the most puzzling and interesting things that scientists are trying to figure out. It takes up about 90% of the mass of a galaxy and can't be seen. One thing that is typical of dark matter is that it can't be found using normal methods. Dark matter is different from other astronomical objects because it can only be seen by looking at its effects on visible objects, radiation, and the framework of the universe as a whole. Observations of dark matter in Andromeda show that stars on the edges of the galaxy have spinning speeds that are about the same as those in the center, which goes against what earlier theories said would happen. This means that dark matter and other unknown particles are affecting and surrounding the galaxy. Along with the studies of Andromeda, it became clear that the halo contains a huge amount of dark matter that goes far beyond the stars that can be seen. Andromeda's halo has a big effect on the movements of star groups and satellite galaxies that spin around it because of its gravitational field. Researchers looked into how orbital motions affect the amount of dark matter in a galaxy and found out how it is spread out. These kinds of studies tell us that Andromeda's dark matter halo is not only very big but also very far out, covering 1 million light-years from the star's center. Also, the nature of the dark matter in Andromeda is not normal. The mass is mostly near the center of the galaxy and spreads out more as you move away from it. This changes how stars form and change over time, affecting gas clouds all over the galaxy. It makes more spiral arms and changes how fast and where new stars form. On top of that, dark matter is thought to have been the main force behind galaxies merging and colliding, shaping the end shapes of these cosmic events. So, one of the most important goals of current astrophysics is to find out what dark matter is. It is supposed to lead to deeper understandings of what the universe is made of and how it evolved. When Andromeda and the Milky Way are about to collide, it's not just two galaxies coming together. Their huge halos of dark matter are also interacting with each other. These unseen halos that surround both galaxies will be pushed around by the crash and will play a big role in how the new galaxy looks. Andromeda's observations helped scientists fill in the blanks about how galaxies formed and changed when the universe was very young. Astronomers study galaxy structures in great detail to find out about the small things that create them and change them over billions of years. These things happen after two galaxies slide together and join, and they include the formation of spiral arms and the growth of a central bulge. This knowledge helps cosmologists change theories of galaxies so that they fit the universe. By comparing how close stars are spread out in space compared to the rest of the universe, signals from Andromeda also help make the cosmic distance ladder more accurate. There are ways to make methods for guessing the size of the universe even more accurate. These adjustments are very important because they explain basic cosmological factors like the Hubble constant, which is used to figure out how fast the universe is expanding. Also, by looking at the stars that make up the Andromeda Galaxy and checking what chemicals they are made of, we can learn about how stars are born and die and how the world gets more chemicals. Now, we have a better idea of how nucleosynthesis and other chemical enrichment processes worked in the very beginning of the world.